All right, where are we at? Oh, I gotta get in the call. Here we are. Oh, so I forgot cloning Git repos has been blue screening my 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 Windows machine lately. So you guys, I think you all understand why I so desperately want us to have distributed compute. I can't I can't maintain computers for the life of me. So it better be easy to move one thing from one computer to the next computer because they don't stick around for long. Okay, is this working? All right, great. All right, that needs to go in the other window. Perfect. Great. All right, this says we're on. Nope, nope. Yes, yes, it does. Okay. All right, so back to it. So we are in the Active Directory verifiable credentials code, which we should not have done in WSL for some reason because the system doesn't like that. So we'll just do it again in Windows land. Nope. Cloning. Okay, and then we cd all the way to here. So is there a tree command in here? Ah, there is. Wonderful. So create your credential. Okay, so, oh no. Oh, oh no. No, 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 no. What is this? We do have to use Azure. I don't want to use Azure. I don't do, I don't. DigitalOcean is the only cloud provider I subscribe to. Um, I don't want to use Azure. Um, I want to use a distributed network of compute. Use these two files to create your credential. Okay. The problem is I don't want to use Azure and I don't want to figure it out otherwise. So this is a non-starter for me personally. Mainly because we need to be able to create these things and I don't understand the full creation flow. All right, what is this? This looks something. This looks like people writing things in Rust. They know what they're doing. Uh, Rust, we have an open issue for. Beta stage, under development, no security audit. Experimental. Well, we're also experimental. FFI, okay. So somebody did a binding to Java, to WebAssembly. We're doing this. All right, here we go. Here we go, folks. Example. Oh God, these people always have their act together. Oh my gosh. Um, let's see. Okay, getting started. Basically, cargo. Try out examples. Okay, examples. Okay, that's what I was looking for. So clone the repo, build the repo, API reference, build the API reference yourself. Oh my God, that's just so put together. Creating an identity. Okay, good. That's a package. Okay, main.rs. Stronghold. Ooh, I don't know. I haven't heard that word before. Is that, what is this? Is this some kind of identity account storage? So is this some kind of, oh, is this a IOTA? Oh, wow, this has come a long way. Is this what I'm thinking of? Maybe it's not. Maybe I was thinking of a hyperledger something. Okay, but this looks fantastic. So this looks great. I think we already have some WebAssembly code that we can integrate. So it should just be a flip switch in development. Verifiable credentials. Okay, so they've implemented this verifiable credentials. So WASM bindings are there for the low level APIs. DID communications. Okay, here we go. See, these people are talking about application level protocols. Um, Okay, of course, robust mechanisms for secure communication already exist. However, most rely on key registries, identity providers, certificate authorities, browser app vendors, or similar centralizations. Many are unsaturated or many are unstructured rich chat only or enable value-add behaviors through proprietary extensions. Oh, are they talking about just messaging in general? Oh, okay, yeah, okay, I see. Many also assume single transport. All these factors permitted asymmetry. Okay, so, but do they have the people from, who do they have involved? They don't have the people from, uh, um, Signal, do they? What is secure key? What are the Signal people again? I'm skeptical if they don't have the people from Signal involved. Hmm. Alice wants to negotiate with Bob to sell something online. Because DIDComm, not direct human communication, is the methodology in this example. Alice's software agent on Bob's software agent. This is exactly what we're saying. Are going to exchange a series of messages. Alice may just press a button and be unaware of the details, but underneath, her agent begins by preparing a plain text JSON message about the proposed sale. Particular selling of irrelevant here, but would describe as a spec of a higher level sell something protocol that uses the IDComm messaging as its foundation. This looks perfect. Alice's agent then gets two key pieces of information from Bob, typically by resolving Bob's DID doc, an endpoint where messages can be delivered to Bob. Perfect. A public key that Bob's agent is using in the Alice-Bob relationship. Perfect. Now Alice's agent uses Bob's key to encrypt the plain text. So if anybody got roped into chill chat, if I roped you into chill chat, this will sound familiar. So now Alice's agent uses Bob's public key to encrypt the plain text so that Bob's agent can read it, adding authentication with its own private key. The agent arranges delivery to Bob. This arranging can involve various hops and intermediates. It can be complex. Bob's agent eventually receives and decrypts the message, authenticating and sending its sender. Oh, God, they did it. Okay. Oh, thank God, this has needed to be done for so long. Ah, yeah, I gave up on this one. I was like, I was not the right time for me. I did not know enough to tackle this one. Um, I think, what did I come down to? Yeah, I think I came down to the fact that you needed attestation because how am I supposed to trust your node to relay my message? Yeah, that's what I came down to. Yeah, and so that's what we're talking about with the review system, and then the attestation. And the attestation is basically you're proving that you're running on what you say you're running on, and then now we're also talking about running basically sandbox code on top of that, just to define an agnostic way to interact with an application from an end user perspective that's programmatic. Um, so like a multi-rest, like a like if instead of passing just a REST call to a API, right, or just a body in a REST call to an API, imagine now that you're passing like a series, like you're passing it a program that it interprets in an execution environment, right, in an execution environment that's sandboxed specifically for that application, and it has automated tooling to do all of the checks on what that sandboxing is required, and then allows for reconfigurability and integration in different places if need be, um, and then maintains that knowledge of what sandboxing is needed in different contexts, in different deployment contexts. Um, yeah, and so that's what we're doing. So, and this is the transport layer, basically, and that's what they're saying. That's what they're saying is there's projects like our project right now who we want to use this. So 2 years ago we did uh, GSOC project to do a distributed server with NATs, a distributed setup with NATs. And we didn't know enough about how this should work then. And so a lot of great stuff got done, but at the end of the day, we didn't we realized we had a lot more to figure out. Um, and so uh, part of that is this is like, well, then you realize you got to build this. You have to build if you want to really come together as a community and run these things together, which we do. Um, because we want to, be able to host things on our own machines and be like, hey, try this new little model that I wrote, right? Or try, whatever, and so that we can all hack together collaboratively, remotely, right? Um, but it's very hard to do that when you're like, you're trying to share your application, with somebody, maybe. So what if you wrote, what I had one earlier, um, like, you know, you write a cool little you just write hello world, right? But you should be able to deploy hello world, to your grandma's iPhone if you wanted to, right? Like you should be able to do that by sending her a text. Um, it shouldn't be hard to make it say like to do the same thing, that you would if you have these predefined relationships of trust in the real world to then extend them to the digital world, and then sort of extend what you would be doing if you were sitting there, right, or like or had the time to go do that, right, but you can just automate all of it because it's all on one shared, well, that's more of like the whole architecture thing and synthesis, but it's yeah, the communications and everything just get breaks down over different use cases. And so the reason why basically so you can solve so that in that use case with the iPhone, and that was bad one for this. That's more of like that's the generic, like what is nice about keeping your basically your declaration of how you want to take your prototypes and put them together, and um, as opposed to actually like compiling is like synthesis is like it's basically the data flows are like this it's like an interpretive language where you can go into any other language, right, or any other. It's just a giant metadata about whatever you're doing. um, very detailed metadata so that you could recreate it, whatever it is that you wanted to do. And so basically what we're saying here in this series where we're going to do this 12 months, right, where we're going to build this, AI software architect is that so 12 months is a short amount of time, and we need to get this thing learning as fast as possible. And that's why we're starting with what is the basis for the communication and for the storage format and for getting things in and out and communicating between nodes, because obviously we're all about massive concurrency and parallelism. So we need to, but to facilitate this communication of all these nodes, um, in this like giant distributed mesh network of whatever compute we can get access to, um, we we can, we don't have to jump through a lot of hoops. We basically, if we want to proxy, you can write anytime you want to get data. Basically, all of the data travels between nodes through this, Web3 interface. Or wait, do we really even? Now I'm actually thinking about this again. Yes, we do need this because so we do need this because this is the use case where you're working together, and we need to assume that we need to just do this right off the bat because this is just going to get too complicated with the trust boundaries and such, later. Or do we? Maybe we should just skip this. Oh, okay. Let's see. Why don't we spend 20 more minutes? So, 12:20. And if we can use something, if we can run some code, um, if we can run some code that will transmit and receive a message, I think we can call it good when we can run with this. Otherwise, we're going to reevaluate what we're doing. Um, and we may move on to the data flows class. Message-based asynchronous simplex. Fantastic. Okay. The dominant paradigm in mobile and web development today is duplex request response. You call an API with certain inputs, you get back a response with certain outputs over the same channel, mostly thereafter. All right, so, think just keep alive over rest. Um, this is the world of Open API Swagger and most RPC for that matter, and it has many virtues. Unfortunately, many agents are not good analogs to web servers. They may be mobile devices that turn off at unpredictable intervals and lack stable connection to the network. They may need to be work peer-to-peer when the internet is not available. They may need to interact in time frames of hours or days. Now with 30-second timeouts, they may not listen over the same channel that they use to talk. So if you're interested in doing embedded device development and stuff like that, this is like, maybe, building these protocols into the low-level drivers on some of these, resource-constrained devices, in yeah, in protocols like Rust or in things like Rust would be some cool projects, or into existing projects that are written in whatever language they already are in to add support. Something like Zephyr would be really cool to add this to. Um, so because of this fundamental paradigm of DIDComm, messaging is message-based, asynchronous, and simplex. Uh, Alice's agent sends message over channel A. Sometime later, it may receive a message which may or may not be a response from Bob's agent over channel B. This is much closer to an email paradigm than a web paradigm. On top of this foundation is possible with elegant synchronous request response interactions. All of us have interacted with their friends. Ah, God, this is just a fuck. This is great. The crowd goes wild. This is fantastic. I love this. I'm so happy somebody finally did this. This just makes me so happy. This is just warms my heart. Thank you, list of people. And encrypted messages. Okay. Let me add it. Okay, what about you? Do you have appendix? Okay, so this is the other thing about this, and this is why, and so you'll say, well, what we can have all these public relays, like um, it's- people will relay things. It's great, it's distributed. Well, okay, but I don't trust them when this information, if you can break these keys 20 years from now, then I'm not sure that I trust them, random people, to relay stuff for me. And that was kind of the conundrum that I ran into. You can set things up, obviously, but everything at the end of the day ends up being like, oh, what domains do you trust? And it's like, but I don't want to have a domain. Like, then I have to have this predefined, like, then you have these CA routes, and Let's Encrypt is great, but like then you're still relying on them, and it's like it just feels like it's not truly distributed in a meaningful way. I think this is. Um, all right, okay, so we'll take them. We'll hope that they also mean freedom here too. I think I may have overreacted. Okay, sweet. Give me the code out of bad messages. Yes. WebSockets. Let me see the WebSockets. WebSockets. Let me see the WebSockets. Ho, 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 ho. This is great. WebSockets. Okay, do you support HTTP2? They never support HTTP2, things like this. So it's like, oh, wait a minute, what? HTTP2? Yeah, that came out like a while ago, but it's much more complicated. HTTP1 is nice and simple. It's great. I don't think I love it as much as the DHCP spec, that's for sure. All right, so show me some code that can do WebSocket stuff. Where are we at here? Issues. Okay. Anybody we know? Different Daniel. We're pretty saturated with Daniels in this space. It's like me and John. There's a lot of Johns in the threat modeling space. Don't know what it is. Messaging. Security and privacy. It works if we need transfer. Okay. Oh, sorry. DIDComm messaging is a powerful way for people, institutions, and IoT things Internet of Things things to interact via machine-readable messages using features of decentralized identifiers as the basis for security and privacy. It works over any transport, HTTP, Bluetooth, SMTP, raw sockets, sneakernet, for example. I don't know what sneakernet is, but I know what SMTP, HTTP, Bluetooth, and raw sockets are, and I like that it works over all of them. And is that it? Is that it? What is this? Hyperledger. And what is this? What is this? Ah, this is so cool. This is so cool. Basic DIDs. What are you guys doing? Seven months ago. Okay. Why? Okay. I am questioning why I'm doing this though, because I think maybe I should just implement the data flows class stuff. Okay, I think we decided that yes, this is a valid way to go. We haven't been able to put a system context in there yet. So we need to know that we can put a system context in there. If we can put a system context in a message, we can consider this a way to go. Now, I'm concerned that they stopped development on this over a year ago. And you may think I'm overly concerned about that, but that mostly not concerned about the content so much as like, is there just something better that we should be using? You know, like this is 4 days ago. So what are people talking about recently? Improve all editorial. Approved by the working group. Okay, so looks like they're actively updating this. And so that's good. So here's the Rust ones. Here's some Go ones. Ah, this is great. They got a few languages. Okay, so we're going to use the Python one. And this is, where's the Hyperledger one? So this is a full pure DID method specification. So what is this? Blockchain independent decentralized identifiers. Uh, is this our buddy? Oops. What is this, Aries? This thing's dead. Okay, so we don't want to use anything based on this. This thing's dead. That's not good. What's up with this? Why is the other one dead? Have we run into a dead end? This would be a train of thought that dead ends situation. So what's going on here? Why is this stuff not being used? Is it just, are we just happen to be the first ones? I'm suspicious. This is too good to be true. Well, I'm excited, I think. This has a good amount of contributors. Oh, and here's this guy. Okay, let's use this one. Here's this guy. This guy put some stuff on here. And he was on the one that's active recently, which is this one. There he is. So so once again we're building these graphs. Who are the key players? Who's involved in what projects? How do you know? You need to understand what code bases do you trust, and what people can you trust who wrote those code bases? What base or and what like things based on what stuff you're seeing like on you looking on Twitter and you're like, okay, so we see that this guy Daniel, he's obviously he knows what he's talking about. We should go listen to him, right? This guy, he seems to be another smart Daniel, so we need to go listen to him. And so if he's working on this one, if they're keeping this up to date, that's a good sign. It's getting updated, like somebody's working on it. It looks like there's a working group we could join. Oh, and they have a Slack channel. Okay, so we can go check that out. But not right now. Okay, so but for now we know that basically, okay, so by association we can sort of trust that this is good. This seems like good stuff right here. Like this is stuff that we can build stuff on top of. We don't have to be too suspicious about this going into thin air, right? It still seems like this is a forward-thinking way to go. Now, I don't know what this is, but it looks French? Question mark? Switzerland? Swiss. Swiss. Oh, okay. So this is that guy from Switzerland. Okay, then this guy says he's from Switzerland, so this must be that org. Okay, yeah, duh. Okay, sure enough. Okay, well, Switzerland. I mean, that's all you need to know. Okay, let's try it. CE demo scripts for details. A general usage of the API is the following: server-side build a message, convert message to a DIDComm message for further transporting by calling one of the following: pack encrypted, pack plain text, build pack encrypted, receiver side, unpack, verify, build encrypted. Ooh, I am just so excited. This is perfect. This is perfect. Holy shit. Oh my God. This is fucking awesome. Oh my God, this is incredible. Oh my God, this is too cool. This is too cool. Years, just years, just years. Sometimes it's just the right time. Now is the right time. Now is the right time for this project. These things, look at all these things that just, um, okay, so everything is just coming together. Okay, we'll go check out that later. Okay, DIDCommsv2. Okay, so this DIDComm v2 is our new best friend. Um, I mean, this is just the coolest thing. Where's Twitter? This is something worth tweeting about. Da, 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 da. Quick. All right, I guess, well, we're still on this, aren't we? Okay, well, this is just great. Okay, so, well, we kind of got burned last time. That's why we're on 5.2. Last time we did a git clone on this computer. So Distributed compute, distributed compute. What do we want? Distributed compute. What do we want it as soon as we can clone this repo? It's the truth. Okay, well, wow, look at that. Okay. Pip install. We got 3 more minutes. 3 minutes. We got 3 minutes to make this happen. I think we can do it. Actually, don't do that. Don't do that. Stop that. Stop. I'll make this a little bit bigger over here. Okay, now this is way too big. All right. Okay. Let's go. Let's go. Let's go. Boom. Copy. Boom. Paste. Thank you for making copy pastable examples with Alice's name in them. Temporary directory. Auth encrypt. Paste. Okay. What do we have here? So let's go check out the demo scripts. We got 1 more minute. Okay. I think we're still. All right, so we're going to fire up nodemon here. We're going to tell it, hey, nodemon. Soon we're just going to say, hey, Alice, do this. Go ahead and watch these files, nodemon. What was it? Okay. Let's try to auto format. I don't understand where it auto format. I don't understand where Vim installs it. Auth nc.py. Okay, now we begin our terrible reward feedback loop. Okay, fantastic. So where are these DIDs coming from? Test vectors common. Okay. Test vectors common. All right. Really, that's that. Well then. Spot. Resolvers config. Where's resolvers config? Okay. Oh, these are fixtures. So PyTest has these things where PyTest likes globals. So they have these things and they're like functions, but then they take arguments. And I think you pass them as command line arguments, but I'm not entirely sure. I don't understand what's going on here. Are they in here? I think they're defined here. Yeah, they're defined here. Resolvers config. Okay, here we go. So this is what we're doing. Secrets resolver ls. See, this is why I really hate this from PyTest and why, but it's nice that PyTest does this because this is a data flow based approach. So it's going to be it should be trivial to extract this information from PyTest, and it's basically it's internal data flow that's keeping right. So that's going to be great. I love it for that, but um, I'm glad that we're going to have a way to make it look a little more organized here. So that's what I have to say about that. All right. Resolvers config Alice. I already all said Alice. How is it? I'm very excited about it. I feel like that was a good choice of name. I think it was a good choice of name. So, all right, okay, focus. So, resolvers config, and I think we decide with non-secrets. So, what does this want? So we need to go back to, there was another conf test. So this is the other one. So resolvers config, just resolvers config in general. Resolver config in general. Yeah, we have this, they have this thing where they'll search through the code for it now, you know. So let's try it. Let's see. I forgot about this. Okay. Test. Okay, see, this is the problem. Test demo 25. Yeah, no. Okay, so this is silly. We're just going to go here and we're going to say, look for this. Because obviously this is not taking us anywhere fast. So here it is. Oh, it is. Wait a minute. It is Alice, but it's telling us resolvers config. Am I looking at the right one? No, we copied. Okay, this is not this because the tests and the tests and the docs are not the same. Okay, this is why. Okay. Where did I miss where we created these? Okay, I probably should read this. Okay. In order to use the library secret resolver and DID's resolver interfaces must be implemented in the application. Implementation of those interfaces is out of the DCOM library scope. Verification materials are expected. DID keys using secret mode must match the corresponding key DIDs from DID doc verification methods. Key DIDs in DID doc verification methods and secrets must have a full DID fragment. Verification methods referencing another DID document are not supported. What? Oh, okay, but we don't care about this. Verification referencing. Wait a minute. What? Verification methods can be embedded. What is this? DID core. Verification methods can be embedded in and reference from properties. Verification relationships as described in verification relationships and referencing verification methods allows them to be used by more than one verification relationship. It's like a ref or something, it's like yeah, it's like one of those JSON schema refs. If the value of a verification property is a map, the verification method has been embedded in its properties and can be accessed directly. However, if the value is a URL string, the verification method has been included by reference and its properties will be needed to be retrieved from elsewhere in the DID document or from another DID document. This is done by dereferencing the URL and searching for resulting resource from a verification method map with an ID protect. Okay, so verification relationships. I don't understand. Is it saying that the spec says no, or is it saying that it just has not implemented it? It says verification methods are not supported. C referring to verification methods. So this implies that the spec says GTFO, basically. I don't think this throws a wrench in anything for us. I think we'll just sort of take it as face value and say, okay, cool. The following curves and art and algorithms are supported. Okay, great. This is where we ask Matt things. Forward protocols implemented. You gotta have crypto. You gotta find a crypto person. Gotta find good math people, crypto people. They are few and far between, and they are incredibly good at what they do. Forward protocol is implemented and used by default. Very, very smart people doing that stuff. Okay, DID rotation from prior field is supported. Okay, that sounds good. DIDComm has been implemented under the following assumptions. That sounds like something I want to read. Do you support CBOR or no? Do they support no? Do DID support CBOR? I think I saw something. Forward alternative endpoint. What is alternative endpoint? Alternative endpoint. Okay. All right, we're just going to trust it. Okay, so how do we get these? I don't understand. I guess we'll see. We'll see when we get because they don't include example. Build a message. Okay. Convert a message from a DID by transporting by calling one. Pack encrypted. Pack encrypted. Build a plain text DID message server set. So pack encrypted. What is the interface on that? And what is this demo again? Okay, so these people have a JVM process and a Python process, and they have a couple little demo scripts. So these are probably going to be our best bet. So, and what's their license? Oh, they don't have a license. Oh, they do. Apache 2, thank God. And what's this? What's the other one? Is that Apache 2 too? Apache 2 too. No, it's the same one. Why is GitHub not detecting Apache 2? Weird. Okay, well, this is great. So, running the demo. Okay, so this demo is gonna, wow, they said people, great docs. Oh man, this is best. Wow, this is great stuff. Oh my God, I am so impressed with this. I mean, oh, wow, they finally did it. This is great. Okay, so init secrets resolver. Okay, I want to know more about the secrets resolver. Is it going to screw us up on the async? I'm worried. Nope. I see async IO. Okay. Come on, secrets resolver. Secrets resolver demo. DIDComm secrets resolver demo. Wait. All right, that's some stuff that we have pulled as well. Distributing demo code within the main package. Secrets resolver. Maybe they did just implement it here. No, it's within the main package. Secrets demo. This is fantastic. Ah, thank you so much. Thank you so much. Oh my God. Oh my God. Ah, Alexander, you rock. What is this? DSR Corporation. This guy is the MVP right now. Okay, whatever he's doing, I hope they're giving him boatloads of money. This is great. Oh my gosh, what a weight lifted. What a weight lifted knowing that this is a problem that has been solved. This is, oh, wow, this is great. I'm so excited. Okay, so this is all, what this means is that all we have to do is implement this class. And so since this is, since what we're doing here, our first objective was, suss out this integration with DIDs, and then we came to DIDComm, which and DIDComm version 2, and then this Python library, and then we found this, and it looks like, okay, maybe it hasn't been updated in quite that long, but what we can also do is we can also reach out to this guy and see what he's been up to, um, and see what's up. So okay, it looks like this is some of the last stuff he did. Well, he might have been making boatloads of money, yeah, and then he just might have stopped, because that is what I just advocated for. So, and good on you, dude. Sweet. Okay, well, we won't bug him then. He's probably just chilling then. I think we can just assume that he kind of cashed out because this is just fantastic. Um, well, being very optimistic here, but I hope so. He deserves it. This is great. This is just I'm ecstatic, quite obviously. So, what is this? This is this other thing. Okay, so implementation of the pure DID. Okay, I think this is too low level for what we want. I think this is what we want. This looks perfect. Okay, where did I put that in here? Okay. All right, so we've confirmed that, it's not going to get all mad at us about this. We want to, go touch the network, for God's sake. Um, we want it to be async all the way down. Um, and so now we just need to figure out how to run some code still. So do we even need to do that? Yeah, let's make sure that we can put something in there. And then we know that, um, so we know that this is going to work. So we know that this is going to work from a um, asynchronous perspective. It looks like those methods, where are they? So it looks like those methods, I don't know where it went now. We've got too many tabs. Um, okay, I lost one now. Okay, so, and I don't think, well, okay, great. Okay, so basically, yeah. So we learned that, there's basically, so we followed, what we did is we followed the train of thought. We if you think about like sort of, there's different problem spaces, right? And people are working within those problem spaces, and this is where we talked about like the W3C and the RCFs and RFCs, and then the ADRs within the individual repos, and sort of how like ADRs, then W3C, then RFC, or like but this is the widest reach, because it's all of the internet, right? And so um, what we did is we said we need this, we want to build this thing, and this thing we want it to be ubiquitous, right? We see a gap in the current uh, uh, deployment environment, and there's people working on this type of stuff, of course, right? This, I think I saw, I think Zelenka, um, Brooklyn Zelenka, I believe. Her company looks similar to this. I saw it, but heavily based on Elixir. It looks like they're doing some really cool stuff there. Um, and Yeah, so this is definitely like an interesting space to be in. I think that adding some machine learning on top of there, and basically just focusing on um, that distributed nature of programming, and the need for us to test our code more and more, and and to make that feedback loop with the ML, and try to get it to sort of go to guide us even more and more, and to help us just make our development in this asynchronous model more effective, right? And then the side effect may eventually be that if we can make this so effective at us collaborating, then take that step and we see if Alice can start writing her own code, right? After she's really helped us communicate better. And Alice is just obviously, the instance, the name for the instance of the entity. And so any instance where you run it, you can name it whatever you want, right? Like um, so uh, great. So yeah, so our Alice is going to be our bot for our project, and so because we had talked about spinning up infrastructure and stuff, and so basically we're just going to wrap all of that is going to get wrapped into, there's the bot. The bot will do all the stuff, right? And so if we want to deploy infrastructure, this will help us keep our infrastructure as code, right? And it will also help us create a distributed network of infrastructure amongst our own machines, as developers on our project where we're very geographically distributed, and maybe have different hardware and different problems on different hardware and just different systems and configs and stuff. And so if we can communicate those environments, right? If we can take snapshot these system contexts, we can then begin to eliminate the it works on my machine or the it doesn't work on my machine problem, right? Because we can say, well, why is your machine different than some other machine, right? Right now we don't know, but we're going to find out, right? Because we're going to capture state, and we're going to capture overlays on upstream, and just we're going to capture a lot of state basically, um, and then we're going to put it in this Web3 network. Um, and likely what we'll do here is so. Uh, what we're seeing here is so Bob and Alice are passing messages to each other, right? And in the event that we are, maybe doing a method call within a data flow execution that's distributed, we may encode the message as the sending operation. We may encode the message as a we may send it to multiple parties, right? So we may send it to the telemetry service or telemetry services, or maybe we're doing this like pull model dev tooling issue is talking about, and we're just sort of sending a notification out to the network, and the network is all the other developers that we're working with, and we say, hey, here's a new change, right? I'm publishing my new change, right? And you can also have these. You could have basically the nice part about using this Web3 message bridge is that now we can take any service, anybody can stand up a service anywhere, and it doesn't have to be connected to HTTP. You don't need a website. You can run stuff in WebAssembly. You can run stuff in your browser because we're going to pass it all through this, right? And so you don't need to maintain servers anymore. You can run your stuff in like base anything that runs WASM. You can run your stuff, right? And what is your stuff? Well, your stuff is defined by these system contexts, these data flows that are living in at least their very most basic form, where they go and get the rest of the data that they need on chain. So that's what we're doing. And then we're going to throw the ML on top of it, um, to basically do automated feature engineering on AutoML and feature engineering across the whole set of data that we see as we throw everything in the network. Yes. God, I'm so happy that they did this. Back encrypted. Okay, are we recording still? Sometimes I'm like, okay, good. Sometimes it's like it's like, oof, man. It's still good. It's still good. It's still good. It's still making progress, but it's better to have the recording, because I'm talking to it and not writing it down, which saves time. Obviously, it also takes time to explain some things, but it's good to explain things because we need to get this all written down of the whole process, right? We need to understand the process. Okay, so I'm a little bit upset about the fact that back encrypted. Pack encrypted. Config. All right, let's just look at the API docs. Or wait, we can. Secrets resolver. Okay, and so there was one that was the secrets resolver. That was DIDComm secrets resolver in memory. Yeah, what does this look like? This looks just like some code that we have. This looks just like the memory, the memory source. Looks just fucking like it. All right. Attachments. What is this? Oh, these guys are in Russia. Attachment. Attachment data. Attachment data. Attachment data. Attachment data. That's it. That's it. That's what we want. Attachment data. There we go. There we go. Okay. Fantastic. Fantastic. This is just the best. I love it. Okay. This is so great. I'm so happy. Resolvers config Alice is not defined. I swear I saw that. I swear I saw resolvers config Alice somewhere around here. Alice, where did you put it? All right, resolvers config Alice. There it is. Resolvers config. Okay, there's this. Resolvers config. Okay. Okay, wait a minute. What happened here? Okay, resolvers config Alice. Okay, so let's define these. Okay, so we're copying that over. Let's go ahead and add let's go ahead and add our SPDX license identifier, our SPDX license identifier. Um, so by doing this, show me, can you just show me, can I just copy paste something for God's sake? There we go. Okay, so by putting this at the top of a file, you remind yourself what your code was derived from. So now I would suggest also putting the upstream URL where you got the source from. This ensures that you can double check very easily that that is the license you think it is, and because you don't want to run down the line and realize you actually switched the wrong tab there, and which is actually, now I'm going to do it again to double check, and it is Apache 2. Okay, great. Yeah, you don't want to, you do not want to be down the line and using the wrong license. Um, okay, no. So now we have to do secrets resolver Alice. All right. Okay, it just keeps coming. Just keeps coming. See, this is why we're gonna get the data flows, and we're gonna get it so that we can introspect. John was already doing, Whiteman was already doing some uh, Python AST parsing. And so we're gonna, and I mean, this is, you don't even need to do AST parsing for this, right? You just load all the files. Then you you just grab all the references. Like, this is not gonna be, this is just, we're just gonna need to get it done, right? It's not like it's gonna take forever. We just, once we get this solid foundation down, where we get this sort of one level, always one level deep execution, um, like the KVM nested setup, um, then it's going to be, I think basically we'll be ironing out documentation and uh, AutoML stuff, and because the current stuff that's in there was probably like the least performant way you could ever possibly do something. I think we have some basics. Obviously, this is why it takes everybody to figure it out. So I think once we get this distributed compute down, um, that's going to make it a lot easier to interact. And once we get this sort of, things, we get this data flow as class, and we get the data flow as class down, and then we do the, yeah, we get the data flow as class down. I think that's going to be really the main one. And then we come up with some more, better syntax for defining the data flows. I think that's going to be really good. I think that's going to be, we're going to be in a good spot there. And then also maybe we also just need to do like introspection. Maybe we could do it where we look at a PyTest test and we enable running it. Maybe we should do that. That's actually really good. That could be a really good course of action. I know some people who run PyTest, so including CVE Bentool. So you could basically take we could experiment with the CVE Bentool PyTests, and we could see if we could write the CLI using only the existing tests or modification, or just only tests. And that way you have the same interface, so you're never duplicating any code, but you're grabbing the argument from these fixtures actually from the command line, or maybe from an HTTP API. because you're importing it to a data flow, and then you can do this transparent, you know, rewiring of things. Um, so, because your data flow is your intermediate representation, that's the cross-language intermediate representation focused on the data, right? All right, let's pack this message. I think I'm probably getting tired here, so let's pack this message. Um, if we can pack a message, then oh man, what is that? Is that sticky? All right, if we can pack a message, then okay, I'm kind of really fed up with the fact that this is not cloned, but I don't want to blue screen again. DID resolver. Come on, just secrets resolver. I want to figure this out tonight. Secrets resolver Alice. There it is. Mock secrets resolver Alice. Okay, and then I think we found all of them. Okay. So these are a lot of different secret keys here. How do we generate them? Uh-oh. How do we generate a key? Excuse me. Hmm. I am not seeing something to mediators unknown to sender. Okay, so this is some kind of, this is something distributed where we have these, okay, so this is good stuff, so. Let's get a screenshot of this. All right. So what is this, and why is it interesting? So this will get into our, uh, yeah, relaying nodes, I believe. I wonder how this is interacting with the distributed web node spec work. We won't won't concern ourselves with that for now. So we just want to make sure that we can encode this message. And if we can do this, then we are good. So secrets resolver Alice, but I also want to make sure that we can actually create keys, because I've gotten into this situation before um, where okay, are these just JWK? What is JWK? Json Web Key. There are all these JWKs. I don't think I've encountered a JWK before. JWK. Let's Google. Json Web Key. Okay, Python. Oh, oh, yes, I have seen this. It's been a while. Okay, how are you supposed to use this? How do we generate one? Okay. So this thing says it can generate these JSON web tokens. So we're gonna try to we're gonna double check that these things work together. So secrets resolver Alice. So secrets resolver Alice had one too many statically defined keys, and I've been in too many times have I gotten into a situation where you start using some library and then all of a sudden you need to generate keys, and it's like, God help you, you're deep in the OpenSSL APIs. You don't want to be there. So they did rewrite it, I hear. So cryptography. Okay. PyCA cryptography. Great. Fantastic. Okay, so how do we install you though? Is this because sometimes they're not the same name and there's somebody typo squatting, so all right, we'll just hope it's the same thing. Or JW crypto. Pip install JW crypto. Okay, so let's capture this. And let's capture this, which was, oh, this is the demo. And this told us to do what? It told us to install DIDComm. Okay, so we're gonna add that. Okay. Secrets resolver Alice. Let's go find that tab. This mock secrets resolver Alice. This is the one we're looking for. Mock secrets resolver in memory. So I think secrets resolver in memory. Okay, so we want this secrets resolver in memory. Why is this mock? Why is it? What's so mock about it? I don't understand. Okay, I think we can just use this secrets resolver in memory. I don't understand. Mock secrets resolver. Oh, because it wants mock secrets resolver. Okay, it's because, yeah, I think I fell into this one time. I think this is our, okay. Mock secrets resolver Alice new DID is this thing, and then this is basically going to do this mock secrets resolver Alice.secrets.values plus mock secrets resolver Charlie.secrets.values, and it looks like I just don't understand what the difference is. This just doesn't look. Get key sync. So what's up with this? Why is it sync? And what is calling this? What is this sync? What is the significance of sync? And what is this? Why is this here? Where does this come from? What is this? Utils. DID specs. Get auth methods in secrets. DID doc spec. Get DID doc. Person. Get key agreement. Okay, so yeah, so oh, I see. You have to have people's keys all set up correctly. Okay. Okay, so we're gonna save things. Yeah, when we save stuff. So when we save stuff, okay. So when we're saving and loading a context, which is the first thing that we're going to do after we do data flow as class, we will encode the context to a we encode the context to inputs as DIDs. And if we do that, then so if you if you encode the input objects because they have these unique identifiers. So, and that's how the input network and such keeps track of them and keeps track of their hierarchy and their lineage. Um, so if you take these input objects and you encode them into the attachment data JSON, the values and the origins and the parents, values, origins, parents, mm-hmm, mm-hmm, okay, value, origin, parents. Now, value is a system context. Could be. The value could be a system context. So each thing, okay, so this is a DID. So we're to have Alice's DID and Bob's DID, and we're going to send all these messages within there. Okay, we're going to send messages. So we have Bob's DID and Alice's DID. And we're going to send a bunch of messages. I'm not sure if we need this. I think that this is good transport layer, but I think, are we one layer? Are we in this layer? Because the attachment data. So let's look at the message format. So body, body, attachments. What are there any restrictions on the message body? Attachments. Okay. Message headers. The DIDComm plain text message conveys most of its application data inside of a JSON body object that is a direct child of the message root. Structure is predicted by the value of the message type, varies according to this protocol. So this is the media, this is the media, or this is the type. Yeah, oh my god, how many times have we all written something like this? The structure inside the body is predicted of the value of message type. However, some attributes are common in many different messaging types. Metadata about a message means the same thing regardless of the context, and when it is susceptible to generic rather than message-specific handling, the metadata can be placed in headers. Headers are siblings of body and may be added to any message type. They are encrypted and decrypted along with body and therefore have an identical audience. Message headers. Okay. So those just looks like the things that we're seeing in the body though to me. Where's the plaintext message? From Alice to Bob, body. Another attribute. Message type specific attribute. Message Okay, ID required, message ID, type required, URI, associates body of plain text message with published and versioned schema. Very important, manifest. That makes this a manifest. So it has, yeah, published and versioned schema makes it a manifest. So published and versioned schema makes it a manifest. Um, what was it? Publish and version schema. Yeah. Okay, which makes it a manifest. Okay, fantastic. So we know we'll throw this thing at the shim. Okay, so now we know how that code is going to get reused. So secrets resolver else indent does not match outer indentation. Okay. Actually, I think that shim code. Yeah, that shim code is kind of, there's some stuff in there that might get reused, but most of it was its own plugin system. Everything ends up being a plugin system. So no, we'll just ditch that. We'll just do it within DFFML. That's why DFFML has to be dependency free. It's just, it'd be nice if it would be a one-line file, I think was the deal, but, or a one single file, but don't want DFFML to be a single file. I don't know if that would be a very good idea. I mean, maybe it would. Maybe we could get it down to a single file one day. I think that would be a good goal. If we could really make it organized, it should be. I think that could be cool. I mean, I guess it will because it'll be a data flow. Well, there you go. Wow. All right. Well, that answered that quick. All right. Okay. So we figured out how to generate a key. So let's just go ahead and print this thing. Okay. All right, so there we go. Okay, so we said import jwcrypto.jwk as jwk. Missing key ID. So jwk.generate did not like us because that's all we did was print it. So let's go figure out where that was. Okay, let's see. What kind of constructed JWS header? Okay, what is this? Data messaging. Okay, what is this? Key IDs. Keys used by specifically both the sender and server user keys derived by a key agreement. Okay, so they're going to agree to use some specific type of keys that they're using both of the same type of asymmetric key is my understanding here. Okay, that's quite a skim, but that's my guess. Protecting the sender identities. They're gonna do something to do that with some math. Auth encrypt. Mandates use of family of content encryption algorithm. It's very difficult to figure out. I always have a really hard time figuring out what the right algorithm I'm supposed to use is. This is why I think you need to really pull this stuff out all the way to where you can say, have this transparency and say, hey, where's all the places I'm using random crypto algorithms? Okay, well, hey, let's have visibility on that because that is not easy to trace through, right? How each one is configured. So if you can use a data flow, you could trace that through. Or, if you can represent it as a graph and properly instrument. Okay, so, all right. So, um, come on. It's almost 2. Is YouTube still going? All right. YouTube is still going. Okay. What did we want? We wanted to generate a key. I think I'm going to go to sleep. Yeah. All right. Okay. Good morning or good night, whenever anybody sees this. And thanks to the DID people, the DIDCommsv2.